The hydraulic power presentation will include a brief system description, a look at the controls and indicators, and a detailed discussion on operation of the A, B, and standby hydraulic systems. The airplane has 3 hydraulic systems, A, B, and standby. Each system has its own reservoir. System A and B are powered by both an engine-driven and an electric motor pump. The standby system has a single electric motor pump. Each of these systems provides hydraulic pressure to its using units. All 3 reservoirs are pressurized by air from the pneumatic manifold. The standby reservoir's fluid level is filled by a line from the B system reservoir. Pressurization of the reservoirs ensures a positive fluid flow to all hydraulic pumps. The hydraulic power using units are the flight controls, autopilots, thrust reversers, landing gear, brakes, and nose wheel steering. Now let's look at the controls and indicators. System A and System B hydraulic pump switches and their associated indicators are located on the overhead panel. Hydraulic pressure and quantity indications are located on the center instrument panel and are incorporated into the Engine Instrument System, or EIS. The hydraulic brake pressure gauge is located on the First Officer's panel. Pilot operation of the standby hydraulic system is controlled from the flight control panel. Control switches and indicator lights provide system operation information. The correct answer is C. The pumps in System A are an engine-driven pump and an electric motor pump. We will now see how System A operates. The System A reservoir has a standpipe for the engine-driven pump. The reservoir should be filled to 88% or higher. A standpipe in the System A reservoir allows the electric motor pump to continue operating if a leak develops in the engine-driven pump or its supply lines. One-way check valves isolate the 2 pumps. The System A engine number 1 pump switch controls the engine-driven pump. The switch is normally left in the on position. The System A electric number 2 pump switch controls the electric motor pump. The electric motor receives power from generator bus number 2. This arrangement provides engine-out backup operation of the hydraulic system. Pump output pressure is monitored by low-pressure sensors. When pump output pressure is below normal, the respective low-pressure light illuminates. System A pressure is indicated by the pointer on the A hydraulic pressure indicator. Normal system pressure is 3,000 psi. Note that the hydraulic system pressure sensor is downstream of the one-way check valves, therefore providing an indication of the combined output pressure of both pumps. Normally, both pumps are operating. However, one pump can provide normal pressure of 3,000 psi. In normal operation, the pumps are cooled and lubricated by hydraulic fluid. This fluid then passes through a heat exchanger located in the number 1 fuel tank. A fuel level of at least 760 kilograms is required for ground operation of the System A electric motor pump. The number 1 engine fire warning switch controls a valve to shut off hydraulic fluid flow to the engine-driven pump. Pulling the fire warning switch closes the hydraulic shutoff valve and deactivates the low-pressure light. If the temperature of the fluid used to cool and lubricate the electric pump is too high, the overheat light illuminates. These are the units powered by System A pressure. They will be discussed in further detail in the landing gear and flight control modules. The correct answer is C. An indication below 88% indicates that System A reservoir servicing is required. System B operates similarly to System A. The System B reservoir has a standpipe for the engine-driven pump and a smaller one for the electric motor pump. Reservoir fluid quantity is indicated on the System B hydraulic quantity indicator. The System B electric number 1 pump switch controls generator bus number 1 power to the electric motor pump. The engine number 2 pump switch controls the output of the engine-driven pump. Together, the pumps provide hydraulic pressure to operate the using units. Individual pump output pressure is monitored by pump low pressure lights. System B pressure is indicated by the pointer on the B hydraulic pressure indicator. Normally, both pumps are used. However, one pump is capable of providing normal pressure of 3,000 psi to the using units. As with System A, the pumps are cooled and lubricated by hydraulic fluid. This fluid passes through a heat exchanger in the number 2 main fuel tank. If the temperature is too high, the overheat light illuminates. The number 2 engine fire switch shuts off System B hydraulic fluid to the engine-driven pump by closing the shutoff valve. The low pressure light is disabled. System B powers these units. Note the relationship to the units powered by System A. Note that the flight controls are powered by both Systems A and B. System B also provides backup pressure to raise the landing gear if engine number 1 fails and for alternate nose wheel steering. These will be discussed in more detail in the landing gear module. The correct answer is B. The engine number 1 fire warning switch disables the engine-driven hydraulic pump low pressure light for System A. Recall that the System B electric motor pump is powered by generator bus number 1. The correct answer is B. With engine number 1 inoperative, the engine 1 hydraulic pump will also be inoperative. With only generator bus number 2 powered, the electric 1 hydraulic pump will be inoperative. The system's A and B pressures will indicate normal with one operating pump in each system. The correct answer is B. Minimum fuel for ground operation of the electric motor hydraulic pumps is 760 kilograms. Now that we understand systems A and B, let's discuss the operation of the power transfer unit, or PTU. The power transfer unit provides an automatic backup source of hydraulic power for the auto slats and leading edge devices. The auto slats and leading edge devices are normally operated by System B. A shutoff valve prevents operation of the PTU during normal operations. The power transfer unit will only operate when airborne with the flaps extended. If the System B engine-driven pump pressure should drop below limits, a signal is sent to open the shutoff valve. This allows System A pressure to operate the PTU. Sufficient pressure is now assured to power the auto-slide operation. With the flaps up, the system will not operate. Let's now look at the standby hydraulic system. If either System A or B fails, the standby system is available for operation of the rudder and thrust reversers and extension of the leading edge devices. Recall that the standby hydraulic pump is electrical. There are three ways to activate the standby hydraulic pump. The pump is activated by positioning either flight control switch to its standby rudder position. Pump operation is also started by placing the alternate flaps master switch to arm. The standby hydraulic system has an automatic operation feature that provides additional rudder force during critical flight operations. The standby pump will operate automatically under the following condition. System A or B low pressure is sensed, flaps are extended, and the airplane is airborne or the wheel speed greater than 60 knots. When the flaps are retracted in this situation, the standby system is automatically deactivated. Whenever the standby pump is operating, the standby hydraulic low pressure light is armed. A low quantity light on the flight control panel monitors fluid level in the standby reservoir. It illuminates any time the fluid quantity in the standby reservoir is low. If a leak occurs in the standby system, the standby reservoir decreases to 0. The System B reservoir quantity decreases and stabilizes at approximately 64%. Note the systems that have backup hydraulic pressure provided by the standby system. Let's look in more detail how the standby hydraulic system operates. The flight control switches have three positions: standby rudder, off, and on. With the switches in the guarded on position, flight control shutoff valves are open, permitting system pressure to operate the flight controls. Low pressure lights below the switches provide an indication of System A or B pressure to the flight controls. In this case, System A pressure to the rudder, ailerons, and elevator is low. The System A flight control low pressure light illuminates. Placing the flight control switch to off closes the flight control hydraulic shutoff valve. This prevents any pressure surges from reaching the flight controls systems. This position is only used for maintenance ground tests of the hydraulic systems. The standby rudder position closes the respective flight control hydraulic shutoff valve, turns on the standby pump, and drives the standby rudder shutoff valve open, providing standby hydraulic pressure to operate the rudder. When the rudder shutoff valve opens, the flight control low pressure light circuit is held open and the light is disabled. In addition, the standby hydraulic system provides the pressure to operate the thrust reversers and leading edge devices. Flight control switch B operation is the same as flight control switch A. The off position closes the flight control shutoff valve. The standby rudder position starts the standby hydraulic pump and opens the standby rudder shutoff valve. When the standby rudder shutoff valve opens, the flight control low pressure light is deactivated. Answer A is correct. System A has failed. The pump low pressure lights and the flight control low pressure light illuminate. Answer B is correct. The standby low pressure light is armed whenever a flight control switch is moved to standby rudder or the alternate flaps master switch is placed in the arm position. This completes the hydraulic presentation. This module covers the non-normal operation of hydraulics, landing gear, and flight controls. Illumination of any light on the hydraulic control panel causes the hydraulic annunciator and master caution lights to illuminate. Illumination of any light on the flight control panel causes the flight control annunciator and master caution lights to illuminate. We will start with hydraulic non-normal indications and procedures. The loss of System A is indicated by the illumination of both hydraulic low-pressure lights, the System A flight control low-pressure light, and when the flaps are retracted, the elevator field differential pressure lights. System A pressure and quantity indicators may also indicate below normal. Refer to your operations manual and study the loss of System A procedure. Answer A is correct. The loss of System A landing checklist calls for manual gear extension. Additional time must be allowed during the approach to accomplish the loss of System A checklist. Answer C is correct. Ground spoilers will be inoperative with the loss of System A pressure. As you can see, the standby hydraulic system provides an alternate power source for the number 1 thrust reverser. Recall that with a loss of System A, the landing gear may be extended manually. The loss of System B is indicated by the illumination of both hydraulic pump low pressure lights, the System B flight control low pressure, and when the flaps are retracted, the elevator field differential pressure lights. System B pressure and quantity indicators may also indicate below normal. Refer to your operations manual and study the loss of System B procedure. Answer C is correct. Outboard flight spoilers are inoperative. The number 2 thrust reverser utilizes standby hydraulic pressure for alternate operation. The trailing edge flaps may be extended electrically with a loss of System B. The loss of both hydraulic systems A and B is indicated by the illumination of all low pressure lights. Both A and B hydraulic system pressure indicators will be below normal. The hydraulic quantity indicators may also be low. Loss of both hydraulic systems A and B requires the use of the manual reversion checklist. Refer to your operations manual and study the manual reversion procedure. Answer B is correct. During a manual reversion approach, limit bank angle to 20 degrees and, in the event of a go-around, 15 degrees. In this case, the ailerons and elevators are controlled manually, and high control forces are required for turns and banks. With the loss of both hydraulic systems, the rudder is powered from the standby system and is very effective. Care must be taken to prevent over-controlling the airplane. Answer C is correct. Neither the landing gear nor the leading edge devices can be retracted after alternate extension with a loss of both hydraulic systems. Answer C is correct. With the loss of systems A and B, the only pressure available for the brakes is the accumulator pressure. In review, the items highlighted are those that have an alternate means of operation with a loss of both hydraulic systems A and B. A hydraulic pump overheat light illuminates. The hydraulic annunciator and master caution lights also illuminate. The corrective action for a hydraulic pump overheat light illuminated is to position that pump switch off. This will cause the low pressure light to illuminate, and the overheat light will extinguish when the pump cools. Turning the pump switch off is also the procedure to be used in case of a hydraulic pump low pressure light. One pump will provide adequate system pressure for normal system operation. The standby hydraulic low pressure light illuminates when the standby hydraulic pump has been activated and the output pressure is low. The master caution and flight control annunciator lights also illuminate. The standby low quantity light continually monitors the fluid quantity in the standby reservoir. The light illuminated indicates low quantity and standby power for the rudder, thrust reversers, and leading edge devices may be inoperative. The standby hydraulic low pressure and low quantity lights are advisory. No crew action is required. This completes the hydraulic non-normal presentation. Non-normal landing gear indications and procedures will be covered next. The wheel well fire warning light and master fire warning switches illuminate. The fire warning bell rings continuously. The first action is to silence the fire warning bell. The recall item for the wheel well fire is to slow the airplane below 270 knots maximum and lower the landing gear. Review the wheel well fire warning procedure in your operations manual. Answer C is correct. If possible, the airplane should proceed to the nearest suitable airport with the landing gear extended. If range is a factor and the landing gear must be retracted, ensure the fire is extinguished and the wheel well area has adequately cooled. Wait 20 minutes after the wheel well fire light has extinguished. Slow to 235 knots, then retract the gear. You are on the ground and the auto brake disarm light illuminates. Turn off the auto brakes. The light will extinguish. Do not attempt a takeoff with the auto brake disarm light illuminated. In flight, the auto brake disarm light illuminates. Turn off the auto brake switch, then reselect a deceleration rate. If the light re-illuminates, turn off the auto brakes and use manual brakes. The hydraulic brake pressure indicator reads 0. This indicates the accumulator has lost its precharge. Brake operation will not be affected with normal System A and B pressure. The anti-skid inoperative light illuminates. This indicates a fault has been detected by the self-test feature of the anti-skid system. Position the auto brake selector to off. Brake with caution. The landing gear lever cannot be moved to up after takeoff. Probable causes are failure of the air-ground safety sensor or a popped circuit breaker. A landing at the nearest suitable field is recommended. If this is not possible with the gear extended, pull the landing gear override trigger to bypass the safety solenoid and retract the gear on the captain's command. The manual gear extension procedure is used when one or more green landing gear light does not illuminate. Study the manual gear extension and partial or gear up landing procedures in your operations manual. Answer C is correct. For partial or gear up landing, flaps 40 is selected. This completes the landing gear non-normal presentation. Next, we will discuss non-normal indications and procedures for the flight controls. Abnormal flight controls refers to the restricted inputs from the control wheel, control column, or rudder pedals. The jammed controls may be freed by overpowering the affected systems. Both pilots should simultaneously apply force to overpower or free the affected flight control. Corrective action may also include trimming the affected system to reduce control forces. Do not turn off any flight control switches unless the faulty control is positively identified. Alternate flaps operation procedure is used if the flaps fail to extend or retract in response to flap lever selection and no asymmetry is indicated. Position the alternate flaps master switch to arm. The flap lever is then placed to flaps 15. The alternate flaps position switch is held in the down position while the electric motor drives the trailing edge flaps to 15. Additional time is required on final approach as it takes about 2 minutes for the trailing edge flaps to move from up to flaps 15. An asymmetrical or no leading edge devices condition will be indicated by the illumination of the amber leading edge flaps transit light and confirmed by the leading edge device's annunciator panel. Refer to your operations manual and study the asymmetrical or no leading edge devices procedure. An asymmetrical trailing edge flaps condition is indicated by an uncommanded roll of the airplane when a new flap selection is made and verified by a split needle presentation on the flap indicator. Refer to your operations manual and study the asymmetrical trailing edge flaps procedure. Extreme caution should be exercised during this procedure. The alternate flap system should not be used because there is no asymmetry protection and the condition could worsen significantly. A trailing edge flaps up landing will be required when the flap position indicator remains in the up position when flaps 1 is selected. In this situation, the leading edge devices will be extended by using the alternate flap system. An all flaps up landing will be required when you are unable to extend any leading edge or trailing edge device. Answer B is correct. For asymmetrical trailing edge flaps between 1 and 15, set VREF 40 plus 30 knots. The field differential pressure, speed trim fail, and auto slat fail lights monitor system performance. Any light causes the flight control annunciator and master caution lights to illuminate. No crew action is required for any of these lights, as they are advisory only. The Mach trim fail, flight control annunciator, and master caution lights illuminate. This indicates a failure of the Mach trim system. Limit airspeed to 0.74 Mach. A flight control low pressure light illuminates. This indicates low hydraulic pressure from that system to the ailerons, elevators, and rudder. Corrective action is to select standby rudder with the flight control switch. Recall that when the standby rudder shutoff valve opens, the low pressure light will extinguish. The yaw damper light illuminates, indicating the yaw damper has disengaged. Corrective action is to cycle the yaw damper switch off, then on. The speed brake do not arm light illuminates while performing the before landing procedure. Corrective action is to return the speed brake lever to the down detent. At touchdown, manually deploy the speed brakes. A jammed stabilizer can be recognized by lack of stabilizer trim wheel rotation when electrical trim inputs are made. Use the handles on the trim wheels to manually trim the stabilizer. Runaway stabilizer is recognized by continued rotation of the stabilizer trim wheels without pilot or autopilot inputs. The recall item for the runaway stabilizer procedure is to place both stabilizer trim cutout switches to cutout. If a runaway continues, grasp and hold the stabilizer trim wheel. The autopilot is engaged and the stab out of trim light illuminates. If the stabilizer is not trimming, hold the control column firmly, disengage the autopilot, and trim manually. This concludes the discussion of the non-normal hydraulics, landing gear, and flight controls procedures.